Hey everybody, Mr. Longo here to talk to you about solving absolute value inequalities. So inequalities for absolute value take two things. First, you have to know how to solve an absolute value equation, but you also need to know and or compound inequalities, and it's going to tie the two together. And let's think about and or statements. Remember, and are very specific, a small group of numbers. When an or statement has an infinite number of numbers. So let's talk. The absolute value of x has to be less than 4. So let's list a few that would work. -4 would not work, but -3 would, because the absolute value of -3 is 3, and that's less. But also, what's the absolute value of 3? It's still 3. What's the absolute value of a -2 and 2? Both 2, which is less than 4. What's the absolute value of -1 or 1? Still less than 4. And what's the absolute value of 0? And of course, we could have -3.5, -2.9, and all those little decimals in between. But really, if you think about it, only numbers in this range would be less than 4 when you take the absolute value of it. So very small group. And then we have x, the absolute value of x has to be greater than 2. Well, what's the absolute value of a -3 and 3? Still 3, that's bigger than 2. But now we can talk about -10 and 10. That would still be bigger than 2. We can talk about -1 million and 1 million. That would still be greater than 2. So you can see that we have an infinite possibilities that would satisfy it, but only a few that wouldn't. So the only things that would not be greater than or equal to 2 would be something like -1 and 1, because the absolute value of 1 is not going to be greater than 2, or -1, or 0, or of course our 1.5s and all the decimals. So as you can see, there's a much smaller that won't satisfy it. So that's going to help guide you into which ones are ands and which ones are ors. Remember, more possibilities is an or statement, limited possibilities is an and statement. So that means this guy is very limited. That's why it's going to help you to remember that this means less than. When you have an absolute value with a less sign, or less than or equal to, it is an and statement for the compound inequality. When you are talking about a greater, we can say that that is greater, to help you remember that absolute value with a greater than or greater than equal to is going to be an or compound inequality. Okay? And that just makes things a lot easier. So when you're solving absolute value equations, remember, once we had the absolute value to itself, we had to write the original, but we also had to write it again and set it equal to the opposite. But when you're doing inequalities, you also need to change the direction of the sign. So x has to be less than 4, and it has to be greater than a -4. And then when you go and graph it just like we did, we have our -4. We have our +4. X has to be greater than a -4. X has to be less than a +4. And since this is an and statement, it's only when it satisfies both of them. So we have our third level of our and statement. And you are good to go. For the next one, x is greater than or equal to 2. So if x is greater than or equal to 2, what we're going to do is say x is greater than or equal to 2, or x is less than or equal to a -2. Again, you have to change the direction of the sign and make it opposite. So we have a -2 and a +2. So x has to be greater than or equal to the 2, or it has to be less than or equal to the -2. And remember, that's a typical and statement, so we're good on that. You don't have to look for overlap or any multiple cases. Okay? So that's the basics of solving absolute value inequalities. So these right here are just an extension. They're a continuation of what we were doing with solving as well. So remember, when you solve absolute value equations, you need to get the absolute value by itself first, and then you do the multiple. So we're going to do the x plus 2. It's already by itself, so x plus 2 has to be less than or equal to 3. This is a less than statement, so this is and x plus 2 is greater than or equal to a negative 3. So remember, you need to switch the direction of your inequality and change it to opposite. And then you just solve. X is less than or equal to 1, and x is greater than or equal to a negative 5. So now, all you have to do is graph it. So we have our negative 5 and our 1. X is less than or equal to 1 and greater than or equal to a negative 5. Since this is an and statement, we are looking for the most specific range, and it's only in between negative 5 and 1. Okay? Next example, the first thing you have to do is divide by 2, just like we did when we were solving equations. So that's going to give you the absolute value of x minus 5 is greater than 4. Now that we have the absolute value by itself, we have x minus 5 is greater than 4. Or, since this is a greater, x minus 5 is less than a negative 4. And just solve again. X has to be greater than 9, or x has to be less than 1 after you add your 5 to both sides. So here's our 1, here's our 9. X has to be greater than 9, x has to be less than 1, and you are good. That is an OR. That's what it's supposed to look like. Game over. So why don't you pause the video and try the rest of these. I will give you a little tip that there are a few special cases at the end. Give them a try. Okay, so for this one, you should have subtracted 2 from both sides first. That would give you the absolute value of x plus 5 is less than or equal to 6. Now what you would do is split it. You have x plus 5 is less than or equal to 6, less than x plus 5 is greater than or equal to a negative 6. Solve both. X is less than or equal to 1, and x is greater than or equal to a negative 11. When we go graph this, you should have had a negative 11 and a 1. X is greater than or equal to the negative 11, but it's also less than or equal to the 1. Since this is an and statement, it must satisfy both of those constraints, so we are right here in the middle. Okay? The next one, you should have been doing a couple of things. The first thing was dividing by a negative 2. So the first thing that's going to do, remember, whenever you're working with inequalities, that's x plus 4, the absolute value, is less than or equal to 2. Remember, this is still an inequality. And whenever you are working with inequalities, if you multiply or divide by a negative, you change the direction of the sign. So then, all you had to do is split it. X plus 4 is less than or equal to 2. Less than x plus 4 is greater than or equal to a negative 2. Solve both. X is less than or equal to negative 2, and x is greater than or equal to a negative 6. Get your line. Negative 6 and a negative 2. X has to be greater than or equal to the negative 6, but x has to be less than or equal to the negative 2. And is most specific and must satisfy both, so x needs to be between negative 6 and negative 2. So here are some of the special cases we were talking about. So I did not make you solve anything here. X has to be greater than or equal to a negative 5, or x has to be less than or equal to a 5. Now, if we were to graph that, since this is a greater statement, we're going to have our negative 5 and our 5. X has to be greater or equal to negative 5, or it has to be less than or equal to 5. Remember, this is an or statement. And if you were to go back and think about our and or compound inequality video, this means that any number you can think of will be a true statement. The absolute value of 10 is bigger than a negative 5. The absolute value of 1,000 is bigger than a negative 5. The absolute value of a negative 1,000,000 is still bigger than or equal to a negative 5. So everything works, and that's because the absolute value is always positive, and a positive number is always going to be bigger than a negative number. So that's why that guy is all real numbers or an infinite number of solutions. In the other one, we had another special case. And this one, we can just wrap it up and just say that this one has no solution. You don't even really need to graph this one if you remember what I said earlier. Remember, we said absolute value will never be negative. So is it possible for an absolute value to be less than a negative number? No, that just means it's more negative. So this one you don't even need to do. It's just no solution. You can't think of any numbers that's going to be less than a negative number after you take the absolute value. All right, so that's it for absolute value inequalities. This is Longo and I'm out. See you, bye.